Dr. Kai. He will present about challenges of modern satellite operations. He is Chief Product Officer at SAT.io. Dr. Kai, the floor is yours.
Yes, hello everybody, and thank you for giving me the opportunity to speak to you a couple of minutes about the challenges of modern satellite operations. My name is Kai Leidig, and I'm co-founder and CPO of SAT.io. We are located in Stuttgart, Germany. You find it here on the map. As Marek, I will speak less about our product rather than the challenges of satellite operations that we see, according to the title of my presentation. And to answer that question first, so what are the challenges that we see in satellite operations? Again, like Marek, I would like to take the opportunity and have a look a little bit into the past, into the history of satellite operations. Like you see it here on the picture, the satellite missions still today and a couple of years ago, they used to be only those big machines, that big complex satellite missions, which required full control rooms with 24/7 staff in the control rooms operating those machinery. And we still have those missions. They are still working. But the future case that we prominently see is the fact that we have smaller companies launching more and more satellites. We see miniaturization in the satellite industry. We see that satellites are getting smaller, more simple. And what our customers are particularly looking into are operational software solutions on ground to operate this fleet with minimal personal efforts. We see that people are asking about lights out operations. So ideally, in an ideal world, we don't have that big control rooms anymore, but lights out operations and those fleets being integrated into the workflows and the processes and the downstream applications of our customers. So that's a slightly shifted use case of satellite operations that we see. And my talk will be basically about those challenges. So you can call it with a demand for automation, demand for lights out operations, and constellation operations rather than single satellite operations. So if you want to put it into one single sentence. And my talk will be basically about that. So I will speak about the roles and the challenges of satellite operators. So what do software solutions for mission operations need to be capable of? What are the challenges? What are the interfaces that they need to provide? I will speak a little bit about our software architecture, and of course about SAT.io. So again, we are also a software company. We are a spin-off from the Institute of Space Systems at the University of Stuttgart. So we are a very young software startup, and we build products, software products for mission operations. So that's what we do. And again, my talk will be about the challenges and the requirements our software architecture is designed to handle. Topics I would like to avoid are topics of satellite communication and RF. I also won't speak about any satellite protocols, and I would also avoid the security aspects of satellite operations, even though those are challenges as well. But I would say, at least with a speak about security, you could fill an entire webinar. And so I will speak more about general aspects of satellite operations. Just some simple words about myself. So I'm an aerospace engineer. I have a background in satellite operations and satellite constellation operations, multi-mission and constellation operations. I also used to work as a ground systems engineer at the university, as well as for a startup. And I also have a background in system simulation and software test and verification. So in my career, I worked for approximately 5 satellite missions in total in various scenarios. I used to be a PhD student, or did my PhD at the University of Stuttgart. Then I worked 2 years as a ground systems engineer for a Swiss startup called ClearSpace, who's doing a debris removal mission for the European Space Agency at the moment. And now I'm fulfilling the role of Chief Product Officer at CPO, and I'm also the co-founder of our company. And as I said before, we have a very strong background in software, and we develop software for satellite mission operations. And so what is the use case that we see for our software? So the, let's say, average customer that we see, they normally have some technology demonstration satellite, or maybe a precursor mission for a satellite constellation to come. So the normal use case is that there is one satellite that needs to be launched and to be operated. And handling one satellite is comparatively easy. Yeah, so we know that, we've done that for years. So one satellite normally is no problem. Yeah, you develop your system, you integrate your spacecraft, you test and verify it, and then you operate that first satellite. And yeah, handling one satellite, that's pretty much state of the art and no problem at all. But then I would say challenges begin. So as I said, the background is that we want to operate an entire fleet. So the normal use case is that we have then, after the precursor mission, there's a follow-on batch of approximately 1, 2, 3, 4, or 5 satellites, which must be launched and eventually operated from a infrastructure on ground. And that's the point where the challenges begin. Yeah, so handling one system is very simple, but once you're in the position that you operate an entire fleet, things tend to become very complex, and that's not just because of the pure number of satellites that you operate. You also must have your processes, your infrastructure on ground, and handle the complexity that comes attached. And after those 5 satellites, the normal case is that the story doesn't end. So the average case that we see is that companies launch an average number of, let's say, 50 to 100 satellites. Yeah, so we see very ambitious business cases at the moment. And yeah, if you want to launch and operate that number of satellites, you must have in place a very solid and rock solid infrastructure on ground to operate that fleet. And I would like to speak about those challenges in a bit more detail. So just have a look at the standard case of operating one satellite. You have your satellite, you maybe have one ground station that you operate, and that image in the center that shall represent the operational system that you have in place. It's basically a software system that contains everything that you need to operate your asset. And the standard case is very simple. You send instructions to the satellite, you receive telemetry, you receive your data. And what eventually happens is that you provide your data, maybe Earth imagery or some other data, or maybe a service to your customer. And implementing that infrastructure is pretty much straightforward. We know that we are capable of handling that. I believe it's not worth talking about that case for a long time. But now let's see what happens when you want to operate an entire fleet. So you start with your first satellite, and there's a next one coming, maybe another one, and eventually you have an entire fleet that needs to be operated. And then, of course, you have your ground station network, and this might increase as well over time once you widen your business case. And this is already a very heterogeneous system that you operated, and that's already a key thing here. So if you compare that image to the image that you saw before, those systems in the middle here, they used to be designed to handle one specific satellite system. And sometimes we see the case that the mission control software that we have in this centerpiece here used to be compiled specifically for one specific satellite. And that's something that you should not do if you operate an entire fleet. So in this very simple case, you operate a number of satellites which are very identical. So that might be an easy thing to do, but we also see that the operated fleets are very heterogeneous. So you have several bus providers, you have several protocols, and that being said, you must provide a certain level of flexibility in handling all these different protocols and interfaces that you have at this site. And you must be capable of handling an entire system rather than one very specific satellite. And our system is designed to do exactly that. What you also need to be capable of is you need to make a set of different stakeholders very happy. So you have a lot of different people working with your system. You have people testing the satellites, you have engineers, you have the operators, and maybe you have your mission managers who are basically only interested in the key performance indicators of your system, and you need to think about them as well. And downstream, you have all the software infrastructure that you need to be compliant with. So you have data centers where all your payload goes. Some of our customers have booking platforms that need to be integrated. And of course, some of our customers also, they want certain applications and services being integrated with the operational software in the center. And that's something that our software solution is designed to do. And what do we find in such an operational software? Of course, you need to have the right connectors and interfaces in place to connect with the ground stations, to also handle the traffic with your satellites. You need to have command and control capabilities in place that allow the operators to instruct and see telemetry of your spacecraft. You need a very solid mission planning solution, because if you handle a large number of satellites, you don't instruct them manually, you create plans, and you also want to automatize things, and you want to have lights out operations. So the mission planning capabilities must be very strong. You, of course, need flight dynamics. You need to know where your satellite is. And of course, you need the databases to store your information, your configuration, and you need the right interfaces. And those are the crucial elements that you find in our software, and which is designed to handle large, complex fleets. And this brings me to my last slide. I will close my presentation in a couple of minutes or in a few seconds. So we consider ourselves a little bit as an operating system. And what we do is that we have different layers in our software architecture. So in the lowest layer, we have the data abstraction, where we make the connection and where we make the connection to the operated assets very generically, and where we are compliant with very different hardware and software platforms. On top of that, we have the scheduling layer, which will take care of the schedules of each and every asset, and which allows our customers to make long-term plans for our mission. And on top of that, we have an API. So our software solution is cloud-based, and the applications that we offer, they are realized as web applications, and we have several applications in place that conveniently support our users in satellite operations. So we start with the low-level ones. So of course, if you start with a precursor mission, you want all these low-level applications. You want to have command and control features. You want data displays, and of course, you want to run and execute procedures. So we have applications for that. On top of that, we have the more powerful mission planning and resource management applications, which allow you to schedule a system and create those plans. And then, of course, it becomes more and more interesting. So the more advanced your system becomes, the more features you can deploy on top. So once you know your system very well, and once you have a powerful mission control setup in place, you can deploy anomaly resolution. You can also do an advanced planning of your contact. And of course, we can also integrate third-party applications through our API. And just to drop that, we are also working on AI applications, for instance, in that anomaly resolution area, where our software can actively support you with the detection of anomalies in your operated fleet. And with that, I come to the end of my presentation. I thank you very much for the attention. Please contact me if you have any further question. You find here our contact information. You can contact me on LinkedIn or please visit our website. Thank you.
Yeah, thank you so much.